Hi friends, this is Gautam. In this video tutorial, I am going to discuss about understanding packet switching modes. So normally, if the source try to ping from source to destination, so the packet will be received by router. The router, how the packet will be switching from input interface to output interface. So for an example, we can take it this example scenario. So here I am using one router and two different PC. So PC1 to router 1 is one network and PC2 to router 1 this is a different network. So now PC1 wants to ping PC2. So the packet will be comes to the router. The router, how the packet will be switching from this interface FA0 bar 0 interface to FA1 bar 0 interface. So there are three packet switching modes are there: process switching, fast switching and chef. So nowadays all the Cisco IOS by default chef is enabled. So we are using process switching mode as chef. So in this video session we are going to discuss about process switching. So before discussing process switching, how the packet will be forwarding from host PC1 to PC2. So in PC1, if I'm trying to ping PC2 IP, so PC2 IP is 192.168.100.10. So in PC1, my source IP is 10.10.10.10 and destination IP is 192.168.100.10 and source MAC address is 005079666800 and destination MAC should be an gateway MAC address. So here gateway MAC address is CA0138040000. So now the packet will be sent from PC1 to router 1. Again in router 1 it check its routing table and forward that packet. So while they before forwarding that packet, the router will rewrite the layer 2 header. So in layer 2 header, the source MAC address should be fast Ethernet 1 bar 0. So that is CA0138040001C and destination MAC address should be an 005079666801 and source and destination IP should be an 10.10.10.10 and destination IP should be at 192.168.100.10. Now the packet will be sent to the PC2. So again the PC2 replying to the router 1. So source and destination IP should be in same. The source MAC address and destination MAC address will be changing. Again once received the router again change the source MAC address as FA0 bar 0 interface MAC address as a source and destination MAC address as 005079666800. So the source IP and destination IP should be in same and source MAC address and destination MAC address will be changing while the packet will be traveling from source to destination. In case if the source IP and destination IP is changing means definitely the packet will be dropping. So now process switching, how the router will switching the packet from one interface to another interface. So in this scenario the packet is receiving on fast Ethernet 0 bar 0 is a ingress interface input interface and the packet will be switching to FA1 bar 0 outgoing interface is FA1 bar 0. So how the router will be performing switching packet switching. Okay, so in this video session we are discussing about the process switching. So we can see, so this is the diagram for process switching. So this is the router incoming packets and these are outgoing packets. So in that router there are two plans are there: control plan, data plan. So control plan means the router, so using routing protocol it finds out the best path. So the best path should be present in the control plan. So data plan means once the router finds the best path, how the data traffic will be traveling from source to destination. So that should be in data plan. So data plan is used to switching the packet from source to destination. How the traffic will be switching from source to destination should be present in the data plan, and control plan means using routing protocol it will find out the best path to reach the destination. Okay, so in process switching the incoming packets is coming. So this is an ingress interface. So once the packet received in the router, so the router store the packet in the memory, then afterwards the switching function will be run. So the switching function means the CPU, the router CPU involved to find out the destination IP. So it will check the routing table. So for this destination IP, it will check the routing table and what is the next hop IP and what is the next outbound interface. So each and every packet the router will receive, the CPU involved to find out the CPU involved to check the routing table and what is the next hop IP, what is the outbound interface, and what is the outbound interface next hop MAC address. So it will rewrite, the router will be rewrite the layer 2 information. So I said earlier, in R1 router, once receive this packet, then R1 router will send that packet to PC2. So source IP and destination IP should be the same. So source MAC address should be in FA1 bar 0 and destination MAC address should be in PC2 MAC address. So it will rewrite that MAC address and send that packet. So each and every packet the router will receive, the CPU directly, router CPU directly involved to find out the next hop IP and outgoing interface and next hop MAC address. So everything they will find out and rewrite that layer 2 information and send that packet. So that's why process switching is very slow. So and also this is a very older model. Nowadays we are not using the process switching method, because each and every packet, so for one packet they will do this operation. So likewise if 10 packets are coming means each and every packet they will doing the same operation, so it will get delay, latency, and it is very slow. Okay, so this is my example scenario. So here in router R1 I disable chef, so by default chef is enabled. So now latest router and latest iOS, they are by default chef is enabled. So we have to disable the chef and fast switching. So just I will run the process switching. So if you want to disable the chef means give no IP chef. Next interface, go to that interface to disable the fast switching. Show IP interface FA0 bar 0. So interface FA0 bar 0, you have to give no IP route hyphen cache. Enter. So in that interface if you are giving no IP route hyphen cache means the fast switchings will be disabled, and in global mode you have to give no IP chef means chef will be disabled. So same you have to give it to the interface FA1 bar 0 IP no IP route hyphen cache. Okay, so now I enable the fast switching and chef on R1 router. So each and FA0 bar 0 and FA1 bar 0 both interface I given no IP route hyphen cache. So fast switching will be disabled and chef also disabled by default. In global mode you have to give no IP chef. Okay, now process switching is enabled on R1 router. Okay, so here I have to give debug IP packet detail. Enter. Okay, now I am trying to ping from PC1 to PC2. So just go to PC1. So in GNS3 I am using virtual PC. Okay, PC2 IP is 192.168.100.10. Enter. Okay, so I am getting reply. Okay, now go to the R1 router. So we enable the debug IP packet. Okay, so we can take it. So totally 5 packets are sending. So 5 packet. So totally 10 packets. So 5 echo request and 5 echo reply. So totally 10 packets we will get. So just I will take it one packet here. Okay, so we can take it randomly. I'm taking one packet, debug packet. So source IP should be on 10.10.10.10 and destination IP should be on 192.168.100.10. So now this is ICMP type 8, that should be an echo request. Okay, now source is 10.10.10 and destination is 192.168.100.10 routed via RIP. So RIP is routing information base, that is called routing table. So routed via routing information base. So through the routing table that will be routed and it will check the outbound interface. So outbound interface is FA1 bar 0. So FA1 bar 0 is this interface. Okay. So source and destination IP it receive and CPU involve and it will run the switching. So CPU involve to find out the next hop IP address and what is the outbound interface, and as well as what is the layer 2 address for outgoing interface layer 2 address, as well as the next hop layer 2 address. Layer 2 address means MAC address. So source IP. So this is a return traffic. So here we can see. So routed by a routing information base. So routing information base means routing tables. Through the routing table, the packet will be forwarding. So source IP is 10.10.10 and destination IP is 192.168.100.10. So source. So fast Ethernet 0 bar 0 is a input interface, egress interface, and egress interface. Ingress interface means incoming packet and egress interface means outgoing packet. So this is FA0 bar 0 is a incoming packet and FA1 bar 0 is a outgoing packet. So it will switching through this interface and the destination IP is 192.168.100.10. So forwarded. So the packet will be forwarded. So this is the return packet. So return packet we can see source is return packet means echo reply from PC to source is 192.168.100.10 and destination IP is 10.10.10. So it will receiving on fast Ethernet 1 bar 0 in router. So ICMP type 0 means echo reply. So again source is 192.168.100.10. This is a receiving. So the source receiving is FA1 bar 0 and destination is 10.10.10 and outgoing interface is FA0 bar 0. So routed via routing information base. So RIB is a routing information base, that is routing table. So each and every packet the router will runs. So it will runs and it will check the CPU involved and to find out the next hop IP and what is the outbound interface and what is the layer 2 address for next hop. So everything it will be find out. So CPU will be involved means so the router CPU utilization will be very high. If that huge packet will be receiving means it will utilize the CPU fully. So to overcome this we are using fast switching and Chef. So next video session we will discuss about the fast switching. Okay friends, I hope you understand this concept. So if you like this concept means if you like this video means please subscribe and share to your friends, and if you have any queries please drop me a mail to fgowthamraj1@gmail.com, and if you have any queries also in that comment section you can ping me. Okay friends, thank you for watching my video.